Hello, we're Group 23. In this video, we will demo our automated rotating solar plant rack with self-care capabilities project. Our group members include Abigail Michael, Brian Guybeck, Cristina Quiñones, and Melissa Rose. The project goals and objectives include making sure we create a system that will autonomously provide water and soil to a plant, create a system that can ensure its plants grow straight up rather than towards the light source, provide a method for caring a plant when one cannot be present, and create an easy-to-use interface that can be learned in a short period of time.
This is the overall physical design for our project. It consists of multiple systems that are present throughout various layers. At the bottom, we placed our PCB along with all the electrical connections and the motor for the rotation system. This is placed above the water basin with a sealed container for the battery. This container is sealed tight to assure no water can get in. In the middle section, we encounter the rotation system. This features a wheel that is connected to the motor that allows the system to rotate. Another platform is placed on top for the plant to sit on. On top of the system, we placed our potted plant along with the water drip emitter, moisture sensor, and light sensor. This platform is large enough to hold most houseplants. Finally, we encounter the shading system. This surrounds the rest of the design.
This table shows the engineering requirement specifications for our project. The ones highlighted in this table will be demonstrated in this video. The first one shows that the irrigation system must be operating at a voltage less than 12 volts and must have a response time upon input of less than 10 seconds. The next one is to show that the light sensor is capable of detecting more than 1,000 lux and displaying the measurements in less than 1 second. Data from the database in less than 1 second, update the status page in less than 5 seconds, and has a response time of less than 3 seconds.
Here's the PCB for our project design and is the second iteration of the board. Here we have the solar charge controller. These are the pin headers for the solar panel, and these are the pin headers for the battery. This LED indicates when the battery is charging. These are the voltage regulators. This one is responsible for providing 3.3 volts to the sensors and the Wi-Fi module. This one is responsible for providing 5 volts to the relay, microcontroller, motor driver, and moisture sensor. Here we have the Atmega 328 microcontroller chip. This is our motor driver. This is the header for the motor and the rotation system, and here is the header for the motor responsible for the shading system. This is the header for the water pump. This is our relay system. This is our Wi-Fi module. And finally, here's the quick port for the moisture sensor, the temperature sensor, and the light sensor.
Here is the web application for the automated plant system. On the right, we can customize the care routine. And after it's customized correctly, we can submit it by clicking this button. And after that, the code will take a second to upload. But once it's uploaded, it will begin to rotate. So it rotates a total of 180 degrees within an hour. Also, we can demonstrate the working of the irrigation system. Right now, the pot is irrigated correctly, so the irrigation system will not have to deploy any more water. However, if we remove the moisture sensor to simulate a lack of moisture, it will begin to irrigate the plant, so it will stay at a decent level. Okay, so in this next section, we're tasked with testing the 3 sensors that are used to input data for our system. The first of these sensors is the temperature sensor. As you can see, the temperature right now is about 74 degrees. However, when I use my body heat on the temperature sensor, we can see it slowly climb. Right now it's already at 77 degrees, and now it's at 78. The next sensor that we're tasked with testing is that of the light sensor. The light sensor, we can see when we adjust the ambient lighting of the area, should go down. Right now I'm turning down my light. We can see the lux went from 339 to 210. If I cover it with my finger, our lux reading goes down significantly to 10 lux, nearly no lux. And if we turn the brightness on maximum of our lighting, we can see a high reading of about 1,800 lux.
The solar charge controller is responsible for providing solar power to the system to recharge the battery. It can be seen on the PCB. When plugged into a multimeter, the voltage should read 13.3 volts, meaning that it is providing power to the system. Here we have the voltage regulators. This one is responsible for supplying 5 volts. When using a multimeter, it can be seen that the regulator does produce a 5-volt output. The second regulator is responsible for providing 3.3 volts. When using a multimeter, it can be seen that this regulator does produce a 3.3 volt output.
Okay, so one of our specifications that we had to demonstrate was the use of the moisture sensor in order to automatically irrigate the plant. So we have our whole system right here. We have our water emitter on very top. And how this works is the moisture sensor acts as a variable resistor. And it basically is measuring the conductivity between the two leads. And the way we've written our program is that if the moisture level of the soil falls below a certain level, it will turn on the water pump and pump water into the system. So right here, we have the moisture sensor inside this cup demonstrating a saturation of water or a plant that is well irrigated, so there's no water pump going off. However, if I were to remove the moisture sensor, this would demonstrate a plant that does not have water. And once removed, the water pump pulls regularly and the emitters drip water in until there's an acceptable level. In this demo, you can see the operation of the rotational system. Usually, we would set the plant to only rotate once every 30 minutes or so, but in order to demonstrate that it's working properly, we have sped up the interval at which it rotates. This system will ensure that the plant receives an even amount of sunlight on each corner.
This demonstration will showcase the Wi-Fi module from the communication system. Here we have our program being uploaded to the Wi-Fi module on the PCB. This code allows the Wi-Fi module to communicate with the microcontroller on the PCB as well as the database and app. In regards to the microcontroller, the app will be able to send commands that will be used as inputs for the plant care as well as manual control over the shading, rotation, and irrigation systems. The Wi-Fi module will also be able to send and receive data from the database. This database can be accessed by the app at any time and will in turn display the results of the plant status page. As you can see, this code has been successfully implemented. This is made clear by the blinking blue light on the ESP12 Wi-Fi module.
Hi, this is our Automated Plant Systems website. To the left are pages. Home leads to this page. Inputs deal with manual control, including such as sunlight, water, shade. To the third is the copyright, which lists our sources for the website. And last is the plant status, which shows the water level and shading status of the plant. Here are the inputs for the manual control and select a new plant. So therefore, this shows how much sunlight this type of plant would typically need. You have these options. Then with water, you can decide how often it would be watered, every twice a day, once per day, every so on. Manual control deals with the irrigation system, such as turning on and off the water pump, the rotation system to rotate it or not, and each time it will change directions, and the shading system, whether you want to close it or open it. Here is the copyright page, listing all the sources we use to make this website. And then finally, it's the plant status. What's interesting about this, it releases information directly from the plant system to the website to see, hey, what's the water level like, or if the shading system is deployed or not. And if you want to get new data, you either refresh the page or press the request data button. Right now, it's just staying the same. Now finally, I'm going to do a test involving the inputs for our plant. So therefore, I go here, I select some inputs that I want my plant to follow, making sure it's following. So you keep those the same. Press submit. This confirms output was created. Now, this output will be here in our databases. So I will move to that. Okay, so right now, this would be according to our PHP code, in this table right here. So if I go here, I can see my latest entry, which is corresponding to numbers right here. And as you can see, the sunlight input, water input, irrigation, rotation matches with our 5 select options we had on the page. This is the code for the Wi-Fi module, and this will be uploaded and take the inputs just inputted into the database just now and send them to the microcontroller. Soon, this will be displayed on its COM port, what values it holds. You can see these match the values I just inputted into the database. Thank you so much for listening to our presentation. We are so honored to have you here and hope you enjoyed hearing about our project.